This is CPM Calculus Chapter 2, number 67. So we're asked to sketch one function that satisfies all of the following conditions. Okay, so all of the conditions. Does your graph have any asymptotes? Okay, so what are the conditions? The first condition is that as we approach negative infinity, the limit as x approaches negative infinity of our function is equal to 2. Okay? Also, the limit as x approaches 3 from the right of our function is 1. The limit as x approaches 3 from the left is negative 4. And the limit as x approaches infinity of our function is negative 2. Okay, so if we want to sketch this, so here's our x-axis, here's our y-axis. Let me go up 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay. We also have the point 3 is important. Okay, so as x approaches negative infinity, our function equals 2. So as we're going to the left here, we're going to approach and get really close to 2. As we go toward 3 from the right, so whatever so here's 4, 5, 6. So this is 3. As we're approaching 3 from the right, we're going to want to get to 1. Okay, I'm just going to put a little open circle there. As we're approaching 3 from the left, we want to get to negative 4. And as we're approaching infinity, we want to get to 2. Okay, so I just want to see that's 2, that's positive 2, that's negative 2, that's negative 4, that's 1. Okay, so now let's fill in the gaps. Okay, so here's our function. We know for it to be a function, it has to pass the vertical line test. So this is f of x, drawn below. That means these 2 points here at x equals to 3, only one of them can be filled in. If they were both filled in, it would be a relation and not a function. Okay? And we want to, on the left side of 3, so this is the left, right? Left, why can't right? Left, and this is the right. So we know as we're approaching from the left, it's going to negative 4. Okay? So the function can look something like this. Okay? And we see that at 2, it doesn't cross the line at the line y equals 2. Okay? Now, to the right of 3, it approaches 1, and it goes down to negative 2 as x approaches positive infinity. So our graph can look like this. I can bubble in one of these, right? This one stays open. I could bubble in this one and this one stays open. I could leave them both open if I wanted. But basically, our graph looks like this. It never crosses the line y equals to negative 2 over here. Okay? So you could have like so many possible answers. What's it saying? Does your graph have any asymptotes? Well, over here on the left, right, my graph has an asymptote at y equals 2. Over here on the right, my graph has an asymptote at y equals to negative 2. So it does have asymptotes, okay? What other answers could, or what other graphs could also satisfy these requirements? Let me just show you an example that's completely different. Let's say we wanted to approach 3 from the right. So let's say we have an open circle here. We go up, we go down, we go up, we go down. As long as we approach infinity, we get close to that negative 2, y equals negative 2 line. Likewise, on the over here, we can have a function that goes like this, right? It could stop there, it could be discontinuous, it could start again, as long as, see, it could start again, it can even go up here. As long as when we approach negative infinity, we're again at the line y equals to 2. So this blue function, right, could also be our f of x. I'm just call it f2 of x. Just to give you an example of the diversity of functions we could draw with these constraints, okay? And there can be many different answers, but we should always have horizontal asymptotes, no matter what our drawing is or our graph looks like, at y is equal to -2 on the right side and y is equal to +2 on the left side. Okay, so we need to have two horizontal asymptotes, and we have to satisfy these four constraints. Okay, so this ends CPM Calculus Chapter 2, number 67.